Welcome to Easy Elimu Learning Simplified. My name is Eric. I'll be taking you through this topic, geometrical constructions. And for this particular subtopic, we'll be covering construction of regular polygons. And to be specific, we'll be doing equilateral triangle for this lesson. How to construct an equilateral triangle. So what's an equilateral triangle? It is one of the regular polygons, and you want to see how it's constructed. So we have a few questions on the same to help us with illustrations on how to construct regular polygons. Of course, we love to look at what regular polygons are and what an equilateral triangle, and how an equilateral triangle forms part of regular polygons, and how to do the constructions on the same. And then we also have assignment at the end of the lesson to help you practice and to help you gauge on your understanding of the concept as discussed during the lesson. So when you talk about a regular polygon, we mean that all the sides and all the interior angles are the same in measure. They are equal in magnitude. So a polygon is considered regular if all its sides and angles are equal. Examples of regular polygons are like equilateral triangle, a square, where all the interior angles are the same and all the sides are equal. So we have pentagon, a regular pentagon. A pentagon is a five-sided figure, and if you have all the sides being equal in length, then the pentagon can be considered to be a regular pentagon. The same applies to hexagon, and of course all the other polygons, as we have mentioned before. Now, to construct a triangle, an equilateral triangle of side 5 centimeters, the procedure should be as follows. One, you have to start with a line AB, as you can see. So line AB, and of course the length has to be 5 centimeters. Then use A as the center and a radius of 5 centimeters. Make an arc up there. Make an arc up there. Then shift the center to B, but the same radius of 5 centimeters. Make another arc to cut the first arc. Where the two arcs meet, that forms vertex C. So you join A to C and B to C, and you shall have constructed the triangle ABC. It's that simple. It is very, 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 very simple. You don't have to struggle with the procedure. The procedure is very, 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 very basic. So we want to see how you do this. Construct a triangle PQR such that PQ is 5 centimeters. So it's 4.5. So all the sides are 4.5 centimeters. So of course you'll have to start with PQ. So this is 4.5. So let me start by locating P. So that is P. Then from P to Q is 4.5 centimeters. So that is Q. So use P as the center and the radius of 4.5. So you make an arc. Using Q as the center, the same radius of 4.5, you make an arc. That's simple. So you join P. So this is the point R. So you join P to R, and you join Q to R. Just simple as that. Now measure the sizes of all the angles found when a triangle ABC is constructed using a ruler and a pair of compass, such that all the sides are the same. Of course, each of the interior angles is supposed to be 60 degrees. So just a matter of confirming after you have done the construction. So here you want to construct an equilateral triangle of side 6 centimeters. So I'll have to start with AB. So I'll mark A first. So that is A. Then from A to B is 6 centimeters. I measure 6 centimeters. So using A as the center, so make an arc there. So that is where B is. Then using B as this A as the center and the same radius of 6, you make an arc that way. Shifting the center to B, the sharp end of the pair of compasses is landing at B. The same radius is 6 that way. So you shall have located C. So now you join A to, so join A to C. And then B2. That way. So the angles ABC equals to 60 degrees. BAC equals to 60 degrees. And BCA is equals to 60 degrees. Being an equilateral triangle, we expect all the angles to be the same. So you measure that, and these are the answers that we are getting. 60 degrees, 60 degrees, 60 degrees. So we want to construct an equilateral triangle of side 5.4 centimeters. So you do the same thing. You have to locate D first. So that is where D is. Then now I measure 5.4 centimeters. So 5.4. So DE. So E is 5.4 centimeters from D. Then now using D as the center, the same radius of 5.4, using D as the center, make an arc. Yeah, using E as the center, the same radius. Don't adjust, you should not adjust the pair of compasses. Make another arc. Look at the first arc at point F. So you join D to F. And then again you join E to F. And so that is the triangle that we are looking for. So again, all the interior angles are supposed to be 60 degrees. So DEF, EDF, and EFD. They are all 60 degrees. So you expect all the interior angles, these ones to be equal in size, and they're each 60 degrees. So we have a few questions to help you practice on the same, on what you have been learning through the lesson, just how to construct an equilateral triangle given all the sides. Of course, all the interior angles are 60 degrees. So the first one is draw a triangle WXY such that WX equals to XY is equals to YW and 5 on 5. So you measure all the angles. So again here, you expect all the angles to be, that is all the interior angles to be 60 degrees. Of course, again, all the exterior angles will be 120 degrees. Remember, interior plus exterior, as we've discussed previously, should be equal to 180 degrees. So question 2, measure the sizes of all the interior angles formed when a triangle MNO constructed using a rule and a pair of compasses only such that NO equals to MNON equals to ON, and that is equals to 7.4 centimeters. So again, all the sides are the same, 7.4. So each side is 7.4 centimeters. So number 3 is construct an equilateral triangle EFG of side 4.2. So that is what you can attempt when that can be soon as possible. Otherwise, that marks the end of the lesson. Until next time, goodbye.